19, 25, etc. Alright, now, Dr. Hunmore was just talking to you about a one-step and two-step process. Here, what we understand to be that common difference each time here, in this case, what is it? It's 6, 6, and 6, and it is one step. Right, and for us it means the same as a constant common difference of 6 between the successive terms. Constant common difference of 6. However, the way that we approach this one, similar to the last problem that was done, the nth term, we work directly with what the nth term formula is going to be. And of course it's going to be linear. You can see it's there. There will be a constant. It'll be in terms of n, the term number, and then there will be another constant. Right, it must have that form. Alright, this is the one that you know. An equals a1 plus n minus 1 times d. Like that. Now, I can write that as a1 plus n times d minus d. And then I can put this constant here. This is a constant. Put them together, and what would we have? We'd have d times n. And here we would have a1 minus d. Like that. Here in the formula, right, the d is in fact the a here. And here, the a1 minus d, that's our constant there at the end. But it's the same algebraic form. This is linear. There's no powers there. The power is 1. Similarly, this is linear. So that's what we're going to work with, this. So if you see just a simple arithmetic sequence, right, it's okay to go directly to the linear term like this and say, alright, it must be of this form. Not just use the general form. Does this bother you, this one? No. Well, that's what we work with all the time. This is for an arithmetic sequence. This doesn't pop up by magic. It must come from somewhere. Right, and I'm saying to you is that's a constant. And d in the common difference is a constant. Alright, so if I just expand out the bracket, I get nd minus d. Here's just a simple number. Here's a simple number. The first term, the common difference, if I put them together, that's the constant b. And here, n times d here, this d here is in fact, that's the coefficient that's going to appear there in front of the n. But we don't use that. For simplicity, we use a and b. But it comes from this. It comes from there. Alright. Now, let's do the problem and see if we can get the solution. Alright, so I'm going to use this. An equals an plus b. Alright. How many unknowns? If I know what a is and I know what b is, then I can work out what the nth term is. It'll just be a simple linear expression. But I need to know a and b. There are here two unknowns. Two unknowns, I need a minimum of 2 equations in those two unknowns. If I've got them, I can solve for the a and b. I can work out what the nth term is. Alright, so here we go. I'm just going to simply apply the formula. So, let's see. The first term is 7. So, a1 equals 7 equals. Now, I don't know what a is. I do know what n is. N is 1. So it'll be a times 1 plus b, just simply a plus b. Alright, next one, 13. 13 is the second term. It'll be a times 2 plus b, or 2a plus b. Like that. Alright, now, here's equation number 1. Here's equation number 2. And what have we got really? I've got a plus b equals 7. There's number 1, and this one, 2a plus b is equal to 13. That's number 2. Well, see, fortunately the coefficient of the b here is both 1 in both cases. If I just subtract equation 1 from equation 2, things will start working for us. Here we go. 2 minus 1. 2a minus a. B minus b, 0. 13 minus 7, 6. So we've got a equals 6. Alright, now with a equals 6, if I go and sub here, 6 plus b equals 7. So sub in 1, what do we get? 6 plus b equals 7. So b equals 1. Alright, now what does it mean though? Here, this is what we say the nth term must be. And what have we solved? We've got b equals 1, and here we've got a equals 6. So the crunch of it, here, the nth term must be what? Alright, here a is 6, so it's going to be 6n plus b. And what's b? B is 1. That's it. That's the nth term.